Hello and welcome to Technology Training, Getting Started with the Smart Manufacturing Innovation Platform. My name is Olivia Morales and I am a Solutions Architect here at CESMII. Today we'll be talking a little bit about what smart manufacturing is and what current challenges exist in manufacturing, how information models can help with those challenges, and then we'll go into how the Smart Manufacturing Innovation Platform actually applies those concepts by defining equipment types or information models, moving the data into the platform from a connector, and then using the data within the platform to visualize it and be able to make some decisions. Then I'll go over a little bit about how the platform is open but secure, because there's the ability to manage your users, and how authentication is used to make sure that your data is secure when moving to and from the platform. I'll go over a few additional resources in case you want more information or you have further questions. As we go through some of the hands-on stuff, if you would like to follow along, you can do so at sandbox.cesmi.net using the following credentials. Take a screenshot or jot it down now, because that's what you'll need later on. So first thing is, what is smart manufacturing? Hopefully, throughout the Smart Manufacturing Summit, you've gotten some good overviews about smart manufacturing and been able to see some demos of smart manufacturing in action. So maybe this is just a review, but here are the smart manufacturing building blocks and how we see the flow of information working in a smart manufacturing system. There are quite a few technologies that form those building blocks, including the sensing necessary to provide the data to begin with, data contextualization to convert raw data into useful information, analytics to develop insights, and modeling to provide predictive intelligence, and control to take actions, including human action, based on those results. These building blocks need to be connected through the platform, and the platform enables them to interoperate. What's most important, though, is the ability to move that data with the context that will make the data actually useful. CESMII is trying to accelerate smart manufacturing by integrating these building block technologies in a way that is repeatable and useful, and thus eliminating some of the specific barriers that we see existing with smart manufacturing implementation. We want it to be scalable, we want it to be secure, and we want it to be repeatable. However, we understand that there are quite a few challenges that stand in the way of actually making smart manufacturing happen for our members. The first one is interface anarchy. We know that there's a variety of protocols out there, some proprietary, some open source, but there's a variety of unique protocols out there that make it hard to move data to the first level of the smart manufacturing platform. It's an obvious challenge. There's proprietary data access that makes the models that are available within the data hard to access. Just getting data points to a visualization application can require many different solutions and many different types of technology. So we understand that this problem stunts the growth before we even have a chance to implement any type of smart manufacturing. Next is the problem of an alternate evolution between the IT environment and the OT environment. We've seen within the software development community who, they've graduated college with information model built into their minds. We expect them to solve problems in an object-oriented way where repeatability and structured programming is natural. Whereas in automation technology, it evolved out of wiring diagrams and through ladder logic. This created a little bit of inconsistency when assembling an object model, because each vendor had its own ecosystem to lock you in to their vendor and keep you buying their products. At SMIP, we're trying to reconcile these two technologies. The industry is responding by assembling after-the-fact object models that get layered on top of the operation technology system, which solves some problems, but it creates others. These become unhealthy trees, unwieldy, overly complex, and not necessarily easy to reuse. The next problem is the idea of big data, that if you get all of your information into a data lake, that all you need is the right AI to sort it out. When in reality, that is unstructured data, and that unstructured data can be harmful. Just having a lot of data doesn't change the fact that a machine learning algorithm needs to be trained, and that to train it, you need meaningful data. So if you're moving data into a data lake and it doesn't have any context, then it's not going to be useful for anyone, and you're not going to be able to make any decisions. So we see smart manufacturing profiles as a key enabler that'll help solve those problems. It can be useful at the edge to determine what data to collect and how, vis-a-vis looking at those different protocols and being able to convert them into something that then a core platform can use. And in that platform, you can define an object model and an API that is useful to read the data in and write the data to the platform. And then applications can be built on top of that core platform with the profile, because it can trust that that interface is consistent throughout the other layers. Smart manufacturing profiles are an extension of the OPC UA information model, and they can be distributed to automate the creation of information value throughout a software architecture. When we look at the Smart Manufacturing Innovation Platform, there are three major themes of development. At the lowest level, we have to address the interface anarchy, we have adapters that support the legacy applications and legacy protocols that we know exist in a lot of our membership. Then to address the alternate evolution, we've got a consistent open specification and non-proprietary programmer's interface which is defined by a published smart manufacturing profile and available at secure endpoints to enable a democratic application development. To address that big data myth, we're developing a marketplace of validated smart manufacturing profiles and crowdsourced applications to give manufacturers access to the ready-to-use solutions that they need for energy, efficiency, and predictive analytics. Hopefully that gives you some idea of how we are addressing the challenges within manufacturing and some of the obstacles to achieving smart manufacturing. But just to hone it in, this is the CESMII vision for smart manufacturing. It's having your manufacturing data connected with the context of a smart manufacturing profile, so that all of your manufacturing operation information, from audio and visual to human input to PLC information, can be ingested into an edge, and then that edge can communicate to the platform where the information model is defined, and applications can be built again on that same profile where we can trust the structure of the data is going to be consistent, and anyone can develop an application because they know the structure of the data. They don't need to know the protocol used, because what matters here is the structure. The platform is a way to illustrate the ideas, and it's a way to demonstrate them in the real world. They're open and available to anyone who shares in this vision, but we don't want to write specifications here. We want to actually prove that these concepts work by putting them to work, by solving real world manufacturing problems. So that's why this platform is being used by our members through application and innovation projects to solve the problems and use the platform to define their information models, define profiles, and get value. It's one step towards their smart manufacturing journey, and everyone's in a different stage on that journey. Next, we're going to look at the Smart Manufacturing Innovation Platform itself and how you can use it to apply those smart manufacturing concepts that I just went over. We're going to begin by defining some equipment types, information models, and then we'll move on to getting a connector set up to connect data from the OT network. In this case, we have an OPC UA server. Getting the connector connected to where we have our tag data and pushing that data up to the platform. And then finally being able to use that data within the platform and use the structure of the data to visualize some information coming from the platform. It can be really tempting to start by getting everything connected and just being able to get all of your tags into one spot and make a decision on what to do with it later. But what we really want to push for at CESMII is the idea of starting with a use case and figuring out what information is going to be most important for that use case and defining that information model before you even get any data connected and moving. So in this case, we have a relatively straightforward manufacturing plant. It's a brewery that has a boiler and a masher and a fermentation tank. So for simplicity's sake, today we're just going to be looking at the boiler. And we know that that boiler has a few different parts. It has a pipe in with a measurement, a pipe out, a drum, each have a measurement and an indicator that tells whether or not that part is online or not, whether that sensor is online or not. We've already defined our profile to get here right now. All we have to do now is go into the Smart Manufacturing Innovation Platform and create the equipment type that matches and get the connection from the OT network, the OPC UA server, and have that connect to the platform, and we'll be able to see the data. But without having in our minds what the profile needs to look like, it's a lot more difficult to make sense of it if you get all the data in the platform first. What we're not going to go over today is how the platform can be harnessed to develop a custom application, but just know that there's a GraphQL API that developers can use to build custom applications in Python or whatever programming language you would like to use. And that can be used to then move data in, get data out, visualize it, build a model, build a predictive model, and really harness the capabilities of the platform. So first things first, we're going to define equipment types. I'm going to switch over from PowerPoint and we're going to instead go to the web browser. This would be a good time to go back to the credentials and pull them up so that you can follow along. This is the Smart Manufacturing Innovation Platform. Go to sandbox.cesmi.net to see an instance of it, and you can log in with the credentials I showed earlier. There's a variety of menu items available here for customization. We're not going to go into that today, but just know that there are plenty of YouTube videos that go over all the customization options available to you for your platform. Today, what we're going to focus on is just getting started with the physical model itself. So go to Model, Physical Model, and you'll see a few different sub-tabs that are going to be useful for creating your model, interacting with it, assigning tags to it, and taking action with it. The first thing we need to do, though, is we need to add a top-level place for our use case. In this case, we've got a brewery, so I'm going to create a place called My Brewery, and that place is a site. So once we submit that, this is going to be where we put all of our subtypes and all of our equipment instances. This will be where we look when we want to trend data. It's a way to organize our information models. Next, we're going to go and we're going to actually create the equipment type for the boiler that we defined in the PowerPoint earlier. So to do so, we're going to click on this plus sign. go to add equipment type, and we're going to create a boiler. It is a base type, so it's not going to inherit from anything, and submit. So far, so good. It doesn't have anything else in it, but we're going to add to it the pipe in and pipe out and drum pieces that I discussed earlier. So here, we're going to do pipe in. It shows up down there. And I already realized that I made a mistake. If you think about it, pipe in and pipe out are going to be the same object type. So instead of creating pipe in and a type for pipe out, I can make a generic type pipe and use that type within my boiler. So in boiler, I can add to the boiler pipe in and assign it the equipment type that I've just defined pipe. So far, this is still just going to be a skeleton of our information model. We'll add the attributes that I discussed for the different measurements and online indicators. But first, let's get the skeleton going. So I'm going to add another pipe type to the boiler. It's going to be pipe out. And it's going to be of the same equipment type, pipe. Last, we're going to add the drum. And it's of equipment type drum. There's a drum here that exists already, but unfortunately it's a dryer rotary drum, not a boiler drum. So we're going to have to create a new type for the drum that we need. Let's call it a boiler drum because a dryer drum already exists. Now we can select it and add it to our boiler object. So there you go. The next step is to add attributes for each of these different equipment types that belong to boiler. So let's find our pipe. And by clicking on this little tag icon, you can bring up the attributes for the equipment type pipe. When I add attributes to the equipment type pipe, it'll get added to both the pipe in and pipe out portions of my boiler. So we need the flow rate for the pipe in, submit, and we need the online indicator, and that's going to be a Boolean. Later, we'll assign these attributes to actual tag values from an OPC UA server. Next, we need to add attributes for the drum. Boiler drum. And I'm going to add volume. And I'm going to add an online indicator for that sensor. Also a Boolean. Great. So now I have defined my boiler structure. This is the information model. Next, what we want to do is we want to create an equipment instance because we know that we're going to be using that information model type to get data from our OPC UA server. We're going to be able to assign it tags. So what I'm going to do is, and I'm going to add to the top level boiler East 1. And that boiler is of type boiler as we just created. And its parent is going to be the location, in this case, my brewery. Now, if you go to the structure, you see that we have an equipment instance called Boiler East 1, of type boiler with the parent my boiler, and it contains a drum, a pipe in, and a pipe out. Each one of those has the attributes that we defined on the previous tab: volume and online. And for pipe in, flow rate and online, and for pipe out, flow rate and online, because both of those were based off of the same equipment type. That's great. So next, what we want to do is we actually want to start getting data into the platform from our manufacturing system. To do so, we go back to this model tab and we go to the connectors, download and configure. Now, I know that I have an OPC UA endpoint that has the information available to me on my boiler. So I'm going to add a new connector, and I'm going to call it brewery. And the organization is the Sandbox operating system Windows, because we're going to run it on this PC that has access to the IT and the OT networks. And the connector type is an OPC UA connector type. Just to review, there are a few different types of connectors available to you, or the ability to create a custom connector, but we're not going to get into all of that today. Once you do that, it gives you a little bit of information. You're going to have to download the connector from the platform, use this activation code to make the connection between the connector and the platform, and then give the connector the endpoint for the OPC UA server. So I'm going to download the installer. While it's downloading, I will copy this activation code and kick off the installation. It might take a few moments to set up, and my installation may be a little bit different from your installation. You may have to install some prerequisites, some .NET prerequisites, but otherwise this is what you should see once you start running it. We're going to enter that activation code from before. Next. So now it'll start to install the services. You might have to click accept or yes to make changes on the PC that you're installing it on, but it'll copy the new files and eventually prompt us to enter our OPC UA endpoint. So give that a few minutes. All right, now we're going to enter our OPC UA endpoint. So this is the endpoint that we have. I don't know if it shows up here, but opc.tcp. We have our own CESMII OPC UA server, quick start, that has some good data, simulated data being shown and organized. So we click OK. It'll finish doing the installation, start up the services, and start getting data flowing. If we go back to our connectors and we refresh, we should see that we've got the connector created a few minutes ago. Once the services are fully started up, we'll see that the connector has been activated and eventually that it's running. That data is moving between the connector and the OPC UA server, and then again the connector and our platform. So I refreshed, it's activated, it's running. It might take a few minutes for the connector to actually gather all the tag information, the metadata, the values. So in the meantime, let's explore our OPC UA server and make sure that we're familiar with the different objects that are going to be read into the platform, so that when we go to the platform to look at the tags and assign all those different attributes, actual data values coming from the OPC UA server, we know what the node IDs are that we're looking for. So here I have my demo server that I'm connected to. If I go to the object explorer, I can see that I have a factory with east and west. We're going to go to the east portion, and I have this boiler 1. If I expand it, I see some of the objects that I've defined already in the Smart Manufacturing Innovation platform. So I have a drum, I have my pipe in and my pipe out. And within each of these, I'm going to be able to see the different measurements that I'm going to be looking for. So remember, for the pipes, that measurement is going to represent flow. And for the drum, it's going to represent volume. In the OPC UA server, it's more generic, but we've made it more specific on the platform for our object model, for our information model, because we want that context to be obvious when we're actually reading in the data and using instances of this equipment in the platform. So let's go back to the platform and see where we're at in terms of getting the tag data. Now, it might take a couple of minutes to get it, but let's at least get familiar with where we're going to look for that data, where we're going to look for that tag list. So I went from model to physical model. This is the same place where we defined our equipment types and defined our equipment instance. Give it a second to load. Let's do this again. All right, so we're up. We got my brewery. We're going to go all the way over to tags, because we want to navigate to the tags and be able to look up our connector and see what tags our connector has found. So if I click on tags, I should be able to filter by brewery, which is the name of the connector we created a moment ago. And we have a few ThinkIQ specific tags. And then we have all of these tags that are coming in from our OPC UA server. And that happened in, looks like, less than 2 minutes. So this is what I'm going to use to assign to the attributes of my equipment instance, my boiler equipment instance defined before. We need to be familiar with what the node IDs actually are. So if I look at my drum measurement, I've got it selected over here. On the right-hand side, I can see what the node ID is. And that's going to correspond to what we select for the attribute. Luckily, within the OPC UA server, the naming convention will make it easy to search for the tag names within the platform. But if it's not intuitive, you would use something like this to jot down the node IDs and look for the tags that matched it. We're going to go back. I'm going to go back to my equipment instance, and I'm going to start adding the attributes. So I got my boiler east and my drum. I'm going to go and I'm going to select the volume for my drum, and the tag source is going to be the data source is going to be a tag, and that tag name we're going to look up by filtering again, brewery and drum. So this one is the measurement for the drum, is going to be the volume. Submit. We're going to do the same thing for the on-line indicator. Same drum, but different tag. Submit. Okay, data source is looking good. Let's do the same for the pipe in and the pipe out. Flow rate. So pipe 1001. And online. The last one is pipe out. We do the exact same thing. And once you make this association, you won't have to change it unless you get a new data source, essentially. So we're doing pipe 1002 for the pipe out. And the online indicator for that same object. Okay, submit. So now we have tags associated with each sub-object of my boiler East instance. And now that the data is associated with those specific attributes, I'm going to be able to go and trend the different pieces of information so I can start making decisions and getting insights into the behavior of my system. Again, you can also build out specific applications using the GraphQL API outside of this platform, but I wanted to show you that you can get value from within the platform itself without needing to be a developer, without needing to know how to write a Python script. You can start actually see the data and build out your information models within the platform itself. So I'm just gonna, in case I did that too quickly, what I'm gonna do now is I'm gonna trend some of these data points. It's already being trended for me. I don't have to do any additional configuration. But I just go to these three dots on any of the objects, and then I click trend. So over here, we're trending the volume and the online indicator. If I wanted to trend, so first let's auto scale it because it's really bunched up. We just started getting the data in, and this data is coming in right now. This must have been the moment that I connected my connector and put my OPC-UA server. And right away, we have a bunch of data points coming in. Now, maybe I want to see the data coming in from all of my available attributes for my brewery. So I went to this plus icon right here. I'm going to add some trend lines. I located my brewery. It's all nice and organized for me. I'm looking at Boiler East, and I've already selected the drum. You can tell because it's highlighted in yellow. So let's add just the flow rate for pipe in and pipe out. Click OK. And we got all this data. It's a little hard to look at. So what if we just look at one? Let's just look at the pipe out value. That looks pretty good. Maybe I want it to be auto-scaled so I can get a better sense of how the values are actually changing. Maybe I want to bring back in those different things, and I want to be able to like isolate where all that data actually, when it's actually being collected. If we had more data, we could switch to a different day. We can change the amount of time that we want to be looking at. There's a lot you can do just here visualizing. Obviously, this is simulated data, but if I run it for long enough, you can kind of tell that the flow rate is gradually going up. Let's see if we auto scale again. And let's do the last 5 minutes. Okay. So right away, we're able to gather this important information. And all we had to do was define the structure and connect an endpoint and assign the tags that exist on that endpoint to an instance of the object that we defined earlier. So the prerequisites are, of course, that you have to have an OPC-UA server in this case, or some other connector compatible server or historian that the platform can connect to. If you don't have something like that, there is a way to develop a custom connector or use the GraphQL API to put data in the platform. We're not going to get into that in this segment, but there's going to be plenty of resources available to teach you how to do that if you don't already have a compatible server or historian set up. But if you do, you can essentially start getting things connected and information flowing within a matter of minutes. And I think that that's part of what's so powerful about smart manufacturing and these information models and the platform itself. So again, if I go back to my physical model, you'll see that I had created another boiler in the same organization. What we had been looking at before was this boiler in the east part of the factory. But you'll notice there's also a west portion of the factory, and it has the same structure. So instead of having to recreate an object, all I had to do was go to my equipment, and I have this boiler West 1 that is of the exact same equipment type. And because it's the same equipment type, I inherit all of the same pieces, the drum, the pipe in, the pipe out, as well as all the attributes that go along with it. If I delete it, I can re-add it and show you how it shows up. So I have my boiler West 1, and it's going to be an equipment type. This is exactly what we did before with boiler East. And the parent is going to be my brewery. And just like boiler East. And so the next step would really just be to go in like we did with boiler East and assign the attributes to each, or assign the tags to each of the attributes that we have here. And then we'd be able to trend how the boiler in the East is performing versus boiler West, and maybe notice some mismatches or decreased or increased efficiency. Other things you can do from here, you can develop scripts right on the platform. Again, without having to get the data out of the platform, you can develop scripts and execute them within the platform with this icon here. And I hope that this is a good introduction to the information modeling capabilities of the platform and how those profiles can really help you make sense of the data that you already have available in your manufacturing system. The last thing we're going to talk about today is how the platform can help you manage your users and how the platform handles authentication of requests coming in to the platform to read and write data to the platform. First, we're going to start with user management. There's an admin console within the ThinkIQ Smart Manufacturing Innovation Platform that allows you to control who has access to what within the platform. I'm going to stop sharing the PowerPoint and jump back over to the platform. So up here, if you notice these menus, one of them says Administration. If you click on it, you can select Admin Console and go to log into the Admin Console. From here, you have a variety of options and things that you can control. Things like what the menus look like, general system settings, any extensions that you might want to add. This is where you'll be able to go and customize how you want your instance to look, feel, operate, whatever you need to make it work for you. Today, we're just going to focus on the user portion of that. So if you go to the user settings, you'll notice that you can manage by adding users, adding groups, controlling their access level. If I go to users, I can see all of the users that are available. I can see the user groups and what permissions each of those user groups actually have. This is going to give you control over the ability to add to the platform, add data to the platform, add equipment instances, delete connectors. Really, all the things that we've gone over today are controllable through the user management portion of the platform. What you'll need to have within your organization is a dedicated administrator who is responsible for controlling those permissions. But other than that, it is relatively straightforward, and you get a lot of those user groups for free. If you want to add new user groups or modify existing ones, all of that can be done within the admin console, which is, again, accessible from within the platform itself. The next part that I want to touch on is the authentication that the platform allows you to do and requires you to do. We're not going to go super in depth into how the authentication actually works, but I just want to touch on it a little bit so that you know where it is and you know where to look if you start building out your own custom application. So the way I got to the authenticator page is from Developer Authentication Management. And you'll notice the title says GraphQL Authenticator. This is because this authenticator is what's required to make queries and mutations using the Smart Manufacturing Innovation Platform API. This is going to be what allows you to build out your custom applications if you want to do predictive modeling, if you want to build out your own visualization using the data that's already in the platform. You're going to need to read the data out of the platform using the GraphQL API. And in order to have consistent access, we have these authenticators that can be created and controlled within the platform. You'll notice we've got authenticator names, they have expirations, they also have roles that they're assigned to, which control what you can access when using that authenticator. All of that can be selected when you actually go in and add a new authenticator. I think that you can learn more about this on the GitHub page. I'll show you some resources in a moment to help you get started and learn a little bit more about how to use the platform or get different overviews of different portions of the Smart Manufacturing Innovation Platform. But this is a good thing to know, just so that if you get stuck trying to do your own API, you know where to look. Finally, I want to point you to this list of resources that CESMII has available for you related to the platform. There's a little bit of everything here, something for everyone, whether what you're looking for is more of a general overview, you want to review some of the concepts we went over today. Some of that's available right on the CESMII.org webpage. If you want to go a little bit deeper on some of the profile concepts or learn how the GraphQL API works, you can find all that information within the GitHub. Even if you're not a developer and you're not comfortable looking at code, there's some good documentation on our GitHub that outlines some of the key concepts that we touched on today, but go a little bit deeper as well. If you are looking for help with ThinkIQ, there's a ThinkIQ knowledge base that has a wealth of information for you. And if you want more content like this, where you have someone walking you through different portions of the platform, the CESMII YouTube page has quite a variety of trainings, demos, conversations. It's a great resource if you haven't checked it out. If you have access to our Confluence page, that also has some good up-to-date information and documentation. Now, if you need to contact us, if you have a project undergoing or you have a problem, you can always contact us via the DevOps email, and that goes straight to the platform team, myself included. Or if you would like to work together with the rest of the membership, you can join our Discord channel. And this is a place where we have a few different channels within Discord that allow individuals within the CESMII membership to solve problems together, whether they be specific or general. We've found that the people on there are relatively responsive, and the platform team is on there too. So if you ask a question there, it might be useful for everyone, and that's part of that the community that we are trying to build here at CESMII. With that, I thank you so much, and we'll get on with questions.
Great job, Olivia. Looks like we got some questions coming in.
Great.
I'll try to start from, yeah. So there was a question about where the data is stored. I can hit that one. The backing database is Postgres, PostgreSQL. Most of the instances have their own Postgres database running in a dedicated VM. There are a couple experiments going on with Postgres as a service. Both AWS and Microsoft provide kind of mega scale Postgres, which is obviously a shared service. So we have been experimenting with that, but generally every instance is in its own Postgres database.
All right. So I saw a question, can the platform include ML model building and deployment? So right now, the only sort of scripting capabilities within the platform are the scripting button that I sort of showed for very simple scripts. But because of the GraphQL API, you can build whatever application you want and then use that with the data that's in the platform. So not built in, but if you have your favorite algorithm that you want to use, you can use it with the data that's in the platform.
Yeah, I'll add to that. There's a number of powerful Python libraries for machine learning that you can import and use in the platform. But the pattern that we really want to drive for is to have the execution run outside of the platform instance. So the platform is a data store and normalizer. The app is provided by a vendor. It's really the app that has the value. So you're welcome to use the scripting engine to experiment. A deployment scenario should look like your code in a container or VM that connects to a given platform instance. So the vision for the marketplace is when somebody wants your machine learning algorithm, they pick it from a list of nicely merchandised items, and the marketplace automatically passes you the platform URI and bearer token you'll need to connect. And then you start looking for the types of data that you know how to build predictions against using your algorithm. So the short answer is you can use almost anything. Hey, Dave, there's one there you could maybe tease. Can you explain GraphQL API overview and function? So not too much because we want you to stick around for the next hour.
Yeah, so definitely stick around for the next hour. We go in depth on GraphQL, comparing that to a typical REST API that you would usually see in web development times. But definitely stick around for that second session. We'll be deep diving into GraphQL, how to create some of these different queries yourself, and where some of that documentation is on our GitHub as well.
There's a question about this example only shows the boiler application. Can this be adapted to different process units or manufacturing applications? Olivia?
Definitely. So yeah, I used a simple boiler just for simplicity to walk you through, but there's no real limit to how complicated or simple it needs to be within the platform. And as we build out the tools like the profile builder and the marketplace, you'll be able to harness profiles that have been made already that you can then enhance and import into the platform. That's upcoming stuff.
Yeah, I'll add to that one again. We chose a boiler for this example, but by no means are you limited to a boiler. So the platform already has a library of a number of different process units that you can draw from and customize. So Olivia showed one path to do that. CESMII is also working with industry bodies around the world who are developing standardized information models. What we're lacking right now is a place to publish those. So you can find them in various places. One of the most influential organizations is one called VDMA, and they've published almost 40 information model specifications and a corresponding node set XML, so a computer readable version of this specification that we're working on being able to import into the platform. Those are published on the OPC Foundation website in text form and on GitHub in computer form. And those are a great place to start. They can be a little bit overwhelming because they're very detailed and well thought out, but they cover a wide range of industries and process units. And it's absolutely our guidance that you should start with an expert publication rather than building your own information model from scratch, and then kind of following the path Olivia went down of customizing or extending where you need to. So there's a related question. Could SESMII develop a manual on how to develop an information model and include a guided example? I think that's a great feature request. There's some of our contemporaries in the field have started work on that, and we've reviewed some of them. I think there's a lot of good ideas out there and a few bad ideas, and I think it behooves us to put together some formal material on what we think are best practices, including finding what's already published and starting from there. So haven't got anything to announce today, but I think that would be a great thing for us to work on, and we will look to do that. There was a question on connector connectivity. Do you want to hit that one, Olivia?
Sure. So let me find it. So what if my connector loses connectivity and comes online later? So if you lose connectivity to the OPC UA server or whatever your OT network has, it'll reconnect whenever that connector comes back online. And then there's also the option to historize your tag data so that the connector will, if you have intermittent connectivity issues or, so you lose connection to the platform or something like that, you can historize the data. It'll buffer in the connector until it reconnects to the platform. So you don't have to constantly be checking whether or not it's reconnecting.
Good. Our friend and champion Sudarshan has a question about visual modeling support. So I think I'll take that one. We don't currently have a visual modeler, probably in the way that you're thinking in the platform. But what we are working on is a way to import models from a variety of tools. I don't know any great ones off the top of my head, but if you have a visual modeling tool that you recommend and you would like us to be able to support importing models from that tool, drop us a note and we will look to scope out a project to figure out what it takes to convert from whatever output format that visual modeling tool uses to the standard that we've settled on.
I'll add to that and say that I don't know what the intent of the question was, but I know that within the platform, you can model some of the building blocks of equipment instances that you've, like I made 2 boilers. If I had boilers and a tank where one was flowing into the other in the platform and show that relationship and visualize it there. So sort of customization things that you can build within the structure of the information model.
That's fair. Thanks for catching that. Yeah, I was thinking about the modeling of the individual units or components, but yeah, the relationship between the units can be visually modeled in the process layout diagram. Thanks for catching that. Some questions about cost and deployment scenarios. So SESMII projects are all pre-commercial by definition. So there is no cost, but there are also limited options on deployment. So during your project, you get free access to the platform, but that platform runs in, right now it's an Azure instance that SESMII has negotiated a compelling rate for so that we don't go broke providing these things for free. That is kind of the license for the scope of an exploratory or research project. If that project succeeds and there were a commercial installation planned, we could certainly talk about alternate deployment scenarios and the kind of commercial licensing for that. We haven't got all those terms figured out. We just have the first few projects kind of coming off their research phase and beginning to explore what it would take to keep this thing installed in multiple factories. And so those have been kind of figured out on case-by-case basis. We're looking to develop broad guidance for all projects. Here's what you're looking at for these different deployment scenarios, but we haven't got that yet. So right now, the short answer is it's free as long as you're in a project. So there's a follow-up question. The platform is only for research projects? Nope, there's about a dozen of these commercial installations, but those commercial agreements are not publicly posted, so I don't have pricing for them. And they support a variety of deployment scenarios based on what was negotiated. It's free for research projects, but it's not only for research projects. How many profiles do we have? That's a hard one to estimate. Every project team is making one or more profiles. Any published specification can be automatically turned into a profile. So I'd wager in the neighborhood of 200. That could be low, it could be high. But hopefully this year, as we bring out the profile designer and make it easier to create profiles, and the cloud library with the OPC Foundation to make it easier to find and share profiles, hopefully we see a real proliferation of that. All right, we've got two different sources of questions here, but I think we hit the big ones. Okay, no, there's one good one here. Do you need to have an OPC UA server in the background, or can the platform handle, in this case, wireless sensors or other protocols? And Prakashan had a good answer, but a partial answer. Olivia, do you want to take that one?
I mean, I'm just looking in the chat now. So no, you don't have to have an MQ or an OPC UA server. There's a few different connectors available for you within the platform. Broadcasting to MQTT is an option. Dave will show you a little bit more about how to use GraphQL to get data in and out of the platform. And then you can really send data to the platform from any source that you have. So there's some connectors pre-built for things like OPC UA, OPC DA, other historians, and then World is your oyster by using GraphQL to get data to and from the platform.
Yeah, let me see if I can do the bundled connector list off the top of my head. So for Linux, we support OPC UA and custom connectors. For Windows, we support OPC DA, OPC UA live data, OPC HDA, OSI Pi, and Wonderware Historian. And custom connectors. So the custom connector is a mechanism by which you can add support for any protocol you want. And then GraphQL is a mechanism by which you can do almost anything. And so that's the next session.